It's a pleasure to be with you today, and I'd like to thank all of you joining us from different parts of the world. Before we begin, I'd like to spend
Man,
just 1 minute.
please share your screen.
No, just 1 minute. Before we begin, I'd like to spend just 1 minute explaining where today's perspective came from. My work has allowed me to engage with projects across the fuel supply, chemical infrastructure, engineering, and investment. Also with an international market. The across-sector experience has given me a unique opportunity to observe how this industry is evolving, not from a single company's perspective, but from the interaction of the entire value chain. The core logic I presented today is how to utilize technology and engineering to create deliverable and investable solutions rather than technical itself and all the business investment itself. So over the next 30 minutes, I'd like to share some practical observation on industrial delivery for green fuels and chemical. I hope today's discussion offers us a few useful perspectives for your own business. And now, please allow me to share my screen. Just 1 second. So, everyone can see, can you
Yes,
have my
I can see.
screen?
Yes,
Sure.
I can see. Yeah.
Sure. Okay. This is a topic today. I think it's very easy to understand. Let me start from this image. This image shows much more than a new hydrogen shipment. It reminds me how quickly our industry is changing, reshaping production, transportation, and delivery. For example, okay, for the hydrogen transportation, this is very difficult for human beings, as everybody in this meeting know. I think, for example, magnesium-based and titanium-based solid hydrogen each have very different storage characteristics, leading to complete different delivery and application strategies. Today, designing the right delivery path has become an engineering discipline in itself. With that perspective, let me briefly introduce the U3 Global platform behind those observations. Yes, we got the next page. As we know, green fuels and chemicals don't move through only one industry anymore. A successful project requires production, logistics, infrastructure, financing, and finally end user. If any one of these elements is missing, the project slows down. That's why our business is organized around collaboration instead of individual products. FuelChem here focuses on practical fuel bunkering access. U3X follows infrastructure and project development. Together, they form one industry work ecosystem. The value comes from connecting the whole chain. That approach has guided our work over the past few years by the team behind it. So, yes, our lovely team came from different industry backgrounds, including energy, chemical, maritime, engineering, infrastructure, and investment. But just as importantly, we work with project-based partners across different countries. Depending on the project, we bring in local engineering firms, technical specialists, logistic experts, and legal advisors, and I think financial partners. Yes, we need that. I think this we designed this flexible structure allowing us to respond to very different market conditions. More importantly, it allows us to learn continuously from different regions. Speaking of experience, let me briefly introduce why I'm speaking here today. Yeah, myself. You people, I think, my friend, you can see this picture is more complex, but I give you a very short and brief introduction for myself. Over the past 15 years, my working has centered on industrial investment, engineering projects, energy market, and infrastructure valuation. That experience gradually taught me something important. Technology alone rarely determines whether a project succeeds. Execution does, infrastructure does, financial structure does, marketing time does. Over the past few years, I've also spent considerable time following the development of green hydrogen, ammonia, and the chemicals, and also the related infrastructure. In parallel, my experience in infrastructure invest and rates has also changed how I look at energy projects. Over the past years, those observations have also shaped the evolution of our industrial events. So let's look at how we did. You can regard those pictures as our team activities. Along this journey, we've had the privilege of building relationships with professionals from around the world. Through project collaboration, industry dialogue, and the conferences we have organized. As those conversations continues to evolve, we realized that the industry was no longer discussing products alone. You could see we have our experts, guests from worldwide last year in FuelChem 2025. We are proud that many industry peers have described it as one of the most open private organized industry platforms in China. Today, the real questions are about politics, maritime security, supply chain resilience, infrastructure investment, and where the next generation of projects will emerge. That's why FuelChem 2025 has evolved into Bulkline Summit this year in Shanghai. More importantly, we hope it became a place where meaningful partnership begin and where it contribute to the long-term growth of your business. So let's start the topic today. Now, the main topic today, I don't intend to spend much time discussing which fuel should be chosen. I think this is the international question for a lot of end customers, including shipping companies and factories. But today I won't discuss it because many excellent consulting firms have already covered that subject. And today we have a friend in this meeting. They came from Europe, they are a consulting company, and they did a good job. Instead, I'd like to focus on what happens after the decision has been made. The structure, the execution required to making industry delivery possible. Green fuels are, in many ways, also chemical products. Take ammonia, for example. It can serve as a marine fuel, but is also one of the world's most important fertilizer feedstocks. Green methanol provides another example. When we use a marine fuel, it requires a much stricter quality control, such as particle cleanliness, to minimize engine wear and ensure reliable performance. In other words, certification, yes, certification is no longer just about proving a product is green. It increasingly determines where and how the product can be applied in future markets. Although many green products originate from the same upstream pathways, whether based on green hydrogen or conventional hydrogen, the delivery systems are fundamentally different. As a result, industry delivery involves far more than transporting a chemical product. It requires building an integrated ecosystem. However, building such an ecosystem requires not only industrial participation, but also supportive policy frameworks, and perhaps most importantly, the willingness to invest before the market is fully mature. This is investment policy, I think. Fortunately, we are already seeing encouraging examples around the world. I'd like to share several of these cases with you next. Yes, I like this example because it demonstrates an important idea. Many people see one product, HIFC's industry platform. The same project produces several different products, e-methylene, gasoline, e-LNG, all supported by one certified production system that creates flexibility not only for production, but also for future markets. This is the technical theory for this system. Through process optimization and operational flexibility, production capability can be adapted to different market conditions, significantly improving asset resilience and investment security. There are many process pathways, but built around carbon-hydrogen coupling reaction. Depending on market economics and the downstream demand, the same platform can produce not only green fuels, but also products such as SAF, acetone, and other value-added chemicals. Unfortunately, ultimately, the optimal product mix is determined by long-term economics, market stability, and the commercial returns. Yes, this page. The same thing also influences how we develop the supplier. Of course, the good projects don't appear overnight. They usually follow a very structured development process. This picture shows the process. We develop the supplier. When people ask me, how do you know a supply is reliable? My answer is usually very simple. We don't start with quotations. We start with observation. We follow projects. We monitor capacity. We verify certification. We understand the logistics. We evaluate financing. Not then do we consider commercial cooperation. The process takes time, sometimes years. You can see the picture. But that's exactly where supply reliable came from. It's worthy for us. Reliable supply isn't built by contracts. It's built through continuous validation. Let me give you one practical example. Yes. Early last year, we had the opportunity to work with one of China's leading green ammonia projects. This project is one example, not because of its size, but because of its development process. Before discussing business, we visited the production site. We spoke with engineers. We reviewed the production capacity. We discussed certification, and we look beyond today's production. Could this project support the international market over the next 5 years? That's the real question. Today, green ammonia is only one product in our portfolio. Today, there will be many more. Fortunately, China already has a growing number of projects, different technology, different regions, different production pathway. Together, they form a much stronger supply foundation, and we've seen similar cooperation developing international as well. But sourcing product is only the beginning. The next challenge is moving there. Once the product leaves the factory, a completely different set of challenges begins. Yes, we're dealing with these challenges every day while the product leaves the factory. From this point, the discussion changes completely. For liquid hydrogen, liquid ammonia, and the cryogenic fuels, logistics became part of the product itself. Temperature control, storage time, loading sequence, port infrastructure, delivery window. Every step affects the cost, safety, and the product quality. Today, we already have multi-delivery options, cryogenic ISO tanks, bulk carrier, FSRU facilities, mental hydro containers such as solid and MHX, and even drone-in container solution for small volume e-gas line distribution. Each option serves a different market. For example, MHX ambient temperature hydrogen containers may change the economics of small and medium hydrogen distribution. After hydrogen is released, the containers can be returned and reused. This is a logistic model we didn't have a few years ago. At the same time, cryogenic products such as liquid hydrogen still require highly coordinated infrastructure. The fuel is only one part of the equation. Receiving terminals, storage systems, loading facility, and timing are equally important. That is why when we discuss delivery with clients, we are often discussing infrastructure at the same time. Sometimes we even recommend new receiving facilities or investment partnership, or for the KIM from the reliable delivery. That naturally leads to another question. What actually happens during the project execution? Let me share a few conversations we often have with our clients. Someone say, I found a faster vessel. Then we discover the ISO tanks are not available. Another project secures the tanks, but the destination terminal has no available cryogenic storage. Someone changes the route to reduce carbon emissions. Then the customs requirements for liquid ammonia are completely different at the new port. All the delivery window happens to overlap with maintenance and the bunkering terminal. Nothing is technically wrong, but the project still cannot move, I want to say. This is why we rarely begin with a quotation. Instead, we begin with questions. What's the delivery deadline? Which certification must remain valid throughout the transport? When all of those answers came together, we don't simply have a logistic plan. We have an executable delivery pathway. At the end, every client is really asking only 3 questions. Will it arrive on time? Will the costs remain under control? Can the carbon arbitrates still be verified? If the answer is yes to all 3, then we have done our job. And once a delivery module has validated, it becomes much easier to repeat. This photograph is not one of our own projects, but I like it because in this year, the 23,000-ton liquid ammonia carrier sitting departure from Qinzhou port in China for India. I don't expect India will resell it, something like they resell oil from China to other country. That will cause some big boss, will not happy with India. So it's a joke. Let me go back. It remains us that industry delivery is already happening. Not in zero. In reality, behind one successful shipment are hundreds of operational decisions. This is I want to say something like product quality, scheduling, port coordination, marine insurance, customs, inspection, certification, risk management. Most of these things are invisible. In reality, simplicity is the result of a great deal of preparation. When people look at this map, they often assume it represents exports. Actually, I say connectivity. China coastal ports are no longer simply loading ports. Increasingly, they are becoming industry interfaces, connecting global supply and demand. Methanol may move in one direction, ammonia in another, hydrogen equipment, carbon services, and engineering support may follow completely different routes. The arrows here on the map are international two-way, something like a product move, technology move, capital moves, project moves, knowledge moves. Not around one fixed trade flow, and when logistics network continue expanding, another question naturally follows. How will future costs change? Yes, everybody won't ask the cost, won't ask the price for the fuel for the product. So this page gives me a chance. Before moving to the final section, I'd like to share one observation. People often ask me, when will green fuel become truly competitive? Personally, I think this is the wrong question. The better question is, what will change the cost structure? History tells us the answer is almost always infrastructure. Solar became cheaper because the manufacturer expanded. LNG became cheaper because terminals and the carrier expanded. Container shipping became cheaper because ports became standardized. Green fuel will follow exactly the same path. We will see that in the next 5 years, but we have to action today. Today, China already has several structural advantages, not scale manufacture, a competitive industry supply chain, strong engineering capability, and perhaps most importantly, continuous infrastructure investment. These are national policy for such kind of investment. I think everybody has the idea for that. One example is a hydrogen pipeline. Instead of transporting hydrogen by truck over long distance, China is beginning to connect production bases with coastal industry clusters through dedicated hydrogen pipelines. Projects such as Kangbao Caofeidian hydrogen pipeline and the future Zhanjiang to Hong Kong hydrogen corridor, and not simply engineering projects. They are a future cost reduction projects. Once transportation costs fall, every downstream product becomes more competitive. Hydrogen, ammonia, methanol, synthetic fuels. That's why we spend so much time studying infrastructure, because infrastructure determines tomorrow's market price. And that naturally brings us to the next topic. Where will the future cost advantage came from? Give us an example in technical. Yes. I think this is the most technical example for why the hydrogen price can go down and where is the opportunity to investment. Infrastructure alone does not create a supply capability. We understand it has to be orchestrated. That is one of the core principles behind the FuelChem. Around the world, key technology are advancing rapidly. Large-scale electrolyzers, hydrogen liquefaction plants, cryogenic storage, liquid hydrogen carrier, receiving terminals, digital scheduling. Each technology is valuable, but individually, there are only equipment products. FuelChem connects those capabilities into one delivery system. Instead of asking, where can I buy liquid hydrogen? We ask such question, how can existing infrastructure be orchestrated into a reliable global supplying capability? This is where FuelChem and UserX, our business module, naturally work together. I think that experience can be shared to other companies like us. Future, I think the FuelChem orchestrates today's delivery capability. UserX helps accelerate tomorrow's infrastructure. Together, they shorten the distance between technology and the commercial reality. Now, I'd like to share two projects that, in our view, represents where future manufacturing competitiveness is heading. Solarium is not simple another technical project. We see it as a bankable benchmark. It demonstrates something much more important than scientific innovation. It demonstrates that advanced fuel production can become industrially scalable, commercially financeable, and global deployable. It synthesizes Pathway has achieved a significant engineering breakthrough. More importantly, it already designed around the 10,000-ton industry production scale, with both carbon intensity and production cost approach investable grade expectations. Behind the Solarium is another technical and deserves attention, SDE, the seawater direct electrolysis. In our opinion, SDE is not just another electrolysis technology. It has the potential to reset the economics of renewable hydrogen by reducing freshwater dependency, simplifying infrastructure, and improve deployment flexibility. That changes the investment equation, I think. And the UserX, we are already preparing pilot deploy in different regions with our project partners. Today, our project pipeline includes more than 30 engineering configurations and product combinations. I regard the future industry leadership belongs to those who prepare before the market became obvious. Yes, this is very interesting. In China, in such a time window throughout history, we know new industry have always created new engineering demand. Railway did, steel did, the internet did. Today, the artificial intelligence is doing the same. Data centers are no longer simply digital facilities. They are becoming critical engineering infrastructure. What interests us is not computing, it's energy. Future data center will require continuous, reliable, and low carbon power. I call those green token. That opens entirely new application scenario for hydrogen, ammonia, methanol, and other green fuels. At UserX, we have been following one particularly interesting direction, underwater data center. Why? Because the underwater environment provide naturally cooling. Easy understand? Because of offshore renewable energy can be integrated directly, something like a wind power on the sea. And because green fuels can gradually became part of this distributed energy architecture. Today, China already operates 3 UDC demonstration facilities, one in Shanghai. And the engineering data is encouraged as we receive. In my view, this is not only a technical demonstration, it may become an entirely new infrastructure asset class for developers, infrastructure owners, and long-term investors. This deserves attention today, not 5 years from now. Yeah. I will close with one observation. The next generation of infrastructure will not be built around single technologies. They will be built around integrated ecosystem. Today, while we're talking about the fuels and chemical delivery solution, we have to use another eye, look at other energy module. So that will give us a very broad sight what's the position we are in today's situation. Green fuels, digital infrastructure, distributed energy ports, hydrogen networks, perhaps in the future, small modular nuclear reactor. SMR has entered pilot in some cases. I think I can share some information with our friends later. Each one strengthens the others. This changes how projects are financed, how assets are valued, and how long-term returns are created. As an energy project developer, I regard the focus is not on inventing every technology, but is helping orchestrate those ecosystems into investable projects. Okay, this is I think the final page. Finally, let me a summary what I said today, presented today, based on my experience. The future of green fuel and the chemical procurement is no longer about buying product. That's required two disciplines work together. In the future, companies will not compete only for product. They will compete for supply resilience. And the supply resilience is designed long before procurement begins. I believe it's very simple. Markets don't reward the biggest company. They reward the best connected capabilities. If today's discussion connects us, then it has already created value. Yes, I'm here. I think people, if you're interested in talking with me, you can contact me here. And thank you very much and your attention. Now I'll pass the floor to Cassie.
Okay, thank you very much, Human. Your presentation reminds that the future of green fuels depends on much more than production capacity. So successful projects require coordination across manufacturing, logistics, financing, compliance, and commercial execution. Only when these elements work together can global delivery become reliable. And with that, let's move to today's Q&A session. I've already received several questions before the chat. So for Human, for the first question is, how can companies effectively control the cost of green fuels and chemicals?
Can you repeat the question? Cassie, just now, move around my attention. Can you repeat the question?
Yes. The question one is, how can companies effectively control the cost of green fuels and chemicals?
Okay. This is all the question. I think the cost is much more than product price. Very simple. Everybody can understand from my speech today. From my perspective, I think it consists of 4 major components for the price. Upstream sourcing. understand. I mean the factory price, whether the product comes from directly from the production plant, port inventories, or optimize supply allocation. I think this is the basic price. And the second part is the logistic and transportation. Special for green hydrogen and ammonia, the shipping routes, the multimodal logistics and delivery plan is very, very important and price sensitive. And the third is operational efficiency. This is a very invisible factor, including vessel waiting time. Yeah, if you are a marine company, you can understand how important, how long you stay at the port. And also you have to work with the port coordination and the fuel storage and the turnaround efficiency. This is very, very important for the transportation and operation. And I think that the risk management is also cost. Something like commercial structure, something like procurement strategy, contract design, financing, and the supply security. For example, if you work with a supplier, what I just said, have a long-term supplying contract with the factory, they help you get the contract price, so you can get a very low price basic. If you have no time to discuss with your supplier and you have to get order the fuel, order the chemical in a short time, so you have the high price. So planning is very, very important. And also your partner has to be transparent to you, be honest to you, how much he earned, how much you have to pay. And I think this is very important for bulk business. Many companies focus on the first component without a long-term planning, which work with his supplying cluster partners. In reality, optimizing the entire supply chain often creates a much greater value than negotiation production price alone. This is where our FuelChem business take a different approach. Rather than operating as a traditional fuel trader or port agent, we are not port agent, we are not a fuel trader. In traditional, we participate across the entire delivery chain. Our network includes direct access to emerging global production capacity. So I have to use our foot to work to every plant. I have to understand their technology competitive. That is to say the factory price is the basis. We have to understand their technology is good for price control from the factory, from the manufacturer. But I think the visibility into factory price structure and the coordinate logistic and the port resources is very, very important for your supplying channel partner to control such components. More importantly, by integrating demand across multiple buyers, I think we can create economies of scale that may generate procurement advantages beyond conventional factory-based pricing. I think you can understand. If you buy the fuel yourself, you cannot get the best price, but we can buy that from a scale benefit, so we can share the benefit with our customer. For customers with recurring demand, we also help establish long-term procurement frameworks that improves supply stability, pricing visibility, and commercial continuity. Ultimately, regardless of the procurement model, our objectives remain the same: to deliver transparency, efficiency, structure optimization, and end-to-end compliance throughout the entire supply chain. I think it's quite complex. So this is my answer.
Oh, thanks, Human. A really useful reframing. And moving from the price haggling to full chain cost optimization, the integrated delivery model you described is something a lot of buyers should look at closely. Let's move on. Could you share more Chinese infrastructure case studies in a future session, particularly on hydrogen transportation, downstream applications, and how China's ecosystem is being developed? I see the chat window. There is some questions. It seems like that.
Good question. I'd like to answer. I would probably approach that discussion from three perspectives. First, policy coordination. Yes, this is the top factor. How governments, industry, and the infrastructure planning are aligned to support long-term deployment. But the China government did a good job, I think. The second, technology and engineering integration. I think that's the people like us, and the people in the factory, my friend. They make production, they make transportation, storage, terminals, and end-use applications developed as one coordinated system rather than as the isolated projects. A third, commercial viability, how a sustainable business model is created to ensure projects can operate beyond the policy incentives and generate long-term returns. I think another topic worth discussing is Chinese rapidly evolving standards and the certification system. I have to emphasize this point, very, very, very important for you understand what I'm thinking about China, why they move so fast and move so quick to catch advantage in the world. China is developing its own green standard while actively working together greater international capability and mutual recognition. There are many practical examples behind this process, and I would be very happy to share in the future webinar. I think I can give you a lot of my thoughts and cases. From my perspective, China approach has not been to wait for global rules to mature. Instead, China has focused on building its own decarbonization ecosystem with an open mindset, while continuing to strengthen international collaboration. China moving themselves, and China is opening to collaboration international. So they have very good position. This is my answer, Cassie.
Thank you. It's a great framework. Policy, engineering, integration, and commercial viability. So the point about China building its own standards while staying open internationally, that's definitely one to watch. So the next question is about our next webinar. One audience asked about your July webinar on future energy solutions for data centers. So what are some of the key topics you plan to cover?
Good. Data center, we know, is an energy facility. It has become one of the most important topics in today's digital economy. The discussion is no longer just about electricity supply. It is increasingly about green compliance, energy efficiency, operating cost, and matching different computing tasks with the most appropriate energy resources. For example, China is developing different energy strategies from different computing scenarios. Large-scale AI model training and token generation are increasingly being deployed in Western regions, where abundant, renewable energy is available. While latency-sensitive services such as inference, retrieval, and user interaction remain closer to demand center in the East, something like Shanghai, Beijing, Guangzhou, Shenzhen. The East, you should have a very quick react computing. So the deployment policy is very important to guide the investor have the right direction for their invest. These different workloads require fundamentally different engineering configurations. For us, we also compare technologies such as solid oxide fuel cells, SOFCs, and gas turbines discussing where each solution performs best and how fuel supply chain can support future data center deploy. Ultimately, whether you are, I think in this meeting, whether you are an equipment manufacturer or data center developer or the operator, or infrastructure investor or enterprises purchasing AI and the cloud services. One principle is becoming very, very increasingly clear. The cost, reliability, and the carbon intensity of energy will increasingly determine the competitiveness of digital infrastructure and the token you use. The competitiveness of the digital product built on it. What I mean, the green energy you use, the green token you have. So you have to be green. In your mobile phone, in your video, you have to buy the green token. The green token from the wind, from the solar, and from the storage material, something like fuels, ammonia, hydrogen, methanol. That's exactly what we will explore in our July session. I look forward to have you join us. I will give a lot of information and 1 hour planning in such field. Yes, Cassie, this is my answer.
Thank you. You say that the energy cost and carbon intensity will shape digital infrastructure competitiveness. Next session sounds like a deep dive. Worth marking your calendars that thanks again, human.
Sorry?
So thank you.
Okay.
Thank you once again to Human for his valuable insights, and thank you to everyone for joining today's discussion. So as more greenfield projects move toward commercialization, competitive advantage will increasing depend not only on production capacity, but also on supply chain integration, global delivery capabilities, and cross-industry partnerships. And meanwhile, the Bookline Shanghai Summit will bring you to face where real collaboration takes shape, where we can continue these conversations and explore new opportunities for collaboration. So thank you again for your participation. I'm Cassie Jen, and we look forward to seeing you at our next Bookline time. Okay, have a wonderful day and goodbye.
Bye-bye, everyone.
Bye.
Bye-bye. See you in July.